Welcome again, everyone. Once again, I'm Amina Maldialfai, and this is DSN Ladies in AI Professional Meetup. So, I'm going to be introducing my colleague Chimaoge to come on board and put us through the first part of the section. We'll introduce DSN to you and what we do.
Hello, Amina. Are you still there?
Yes, I'm here. Can you hear me?
Okay. Yes, I can hear you. Okay.
Hi, Chimaoge. Are you still with us?
Yes, I am. Can you hear me, please? Please confirm you can hear me.
Yes, I can hear you. You can proceed.
Okay, all right. Good morning, good afternoon, good evening from wherever you are joining. My name is Chimoge. I want to welcome you into this our program, DSN Ladies in AI, our meetup for this evening. We'll be learning about database. But before we go on, I want to introduce DSN to us in case for people that is joining us for the first time. So DSN, which stands for Data Scientist Network now. Some of us might know it as Data Science Nigeria, but now we go by Data Scientist Network. And our commitment is to raise 1 million AI talents and build AI solutions that improve the quality of life and well-being of 2 billion people in emerging markets. Is that not cool? That is cool, right? So our renewed focus will see us deliver on our vision through a renewed focus on 3 core areas. So we are strengthening our community, we are building products, and we are doing a lot of partnership. So we are working with these 3 approaches right now. Next. Okay, so from 2016, 2021, what have we achieved so far? Of course, everybody knows we have a large learning community. We have a large community which we empower all the time to learn. Our research and our social good applications, our research papers we do all the time. Corporate support and solution deployment to build world-class solutions that will solve problems and contribute to the GDP, right? Startup, support startups and ventures, AI vertical partnership, and AI for national development. So we support startups to help people to start up, okay? Of course, in 2019, DSN was awarded #1 Artificial Intelligence Learning Community and Solution Delivery Network in Africa at Matter Impact Award Deep Learning at Indaba in 2019, which was where our lead mentor, Dr. Bayo, presented. And we were giving this award based on the kind of work we do with community and everything we do to impact people's life in Nigeria and in Africa as a whole, right? Awesome, awesome stuff. Next, please. Okay, so also we won the best academic poster at the 21st edition of the Global Economic and Computation Conference. So we won the best poster. This poster, Share Trust to End Poverty and Promote Financial Inclusion, won the best poster on this conference, which is a mechanism design conference. So DSN is the only African finalist at the 2021 X Prize competition on building advanced AI algorithms to address COVID-19. So we also won this prize. We were just the last Africa finalists at this X Prize competition. Also, DSN work and academic paper presentation at the foremost global scientific and practitioner AI conferences. So we also represent at every AI conference that goes on around the world, New Reefs, Indaba, name them. We also try to represent DSN and Nigeria and Africa as a whole, all the conferences. Okay, so next, please. Okay, so of course, we have an artificial intelligence book for beginners. This is absolutely for beginners, primary school level. because it was designed to that level. It carries animations, which speaks to children, which children can understand very well. So if you want this book, you can order it from any of these links. Jumia, if you're in Nigeria, you can Amazon Kindle, Amazon. So if you want this book, you can order it online. It's very, very good, and it's a very beginner level book, which everybody can relate to. Of course, we have our dedicated AI research lab in our office in Yaba. So anybody that has visited our office will understand what I'm talking about. It is well, it is cool, it is very conducive for learning, and our AI and our robotic lab, which we also have in our hub to help do awesome stuff, right? So you're welcome to come in anytime we are having any physical training and join in whatever that is going on, okay? So we have 2 products initiated, conceptualized and developed by DSN, which were selected in the 2021 Global Top 100 AI Products by UNESCO. Of course, this is a big one for us. 2 of our products were recognized by UNESCO. It is awesome. It's a very good achievement we are proud of. And, you know, we thank God and we are proud of what we are doing at DSN. Okay. Next, please. Okay, so we have dual business model for global impact through DSN AI innovation, career tech, fintech, retail tech, ed tech, everything tech. So education is important, technology is important. So we cut across every part, we cut across every technology sphere in order to create impact and create our products that are going to drive solutions and make life easier. Next, Amina, please. Okay, so also have our DSN AI incubation participation. Last year, we had our DSN AI startup where we had some startup that were set up. If you look here, you see some startup that we worked with, our AI startup lab. So be on ground in case if you are interested, so that you know next time this program will, so you can able to join if you are something you are good at. So the last one is this our board of directors. We have a board of directors. They influence everything we do in DSN. They advise us. They make sure we are going with the right path, and we are working with world-recognized people, world-recognized professionals that are steering us to the right path to make sure that we are doing what we're supposed to do and achieve our target, and above all, build and impact lives in Nigeria to make sure that everything is going on very well. Thank you, Amina. So you can take it off from here. Please sit back and enjoy this class, ask questions when you are confused, and we promise it's going to be a good one. Thank you.
Thank you so much, Chimoge. And once again, welcome everyone. So now that we've heard about DSN and what we do at DSN, we're going to introduce DSN Ladies in AI. The DSN Ladies in AI started in 2020, before the start of the COVID. We launched in March 2020, and there was a first professional meetup supported by Microsoft and some other bodies. And the plan was to benefit, to have a very good and increasing participation and representation of ladies in the data profession. Data profession including everything data, everything, big data, data science, data analyst, data governance, policy, machine learning, robotics, literally everything data. And from there on, so this was how the professional meetup went. And it's very interesting that our speaker for today was also part of those who actually launched the program, Mrs. Opeoluwa, Iwashokun, and I'm very happy that she'll be the one who's taking today's section. And and because we're very keen about gender inclusion in DSN, we have a good representation of females among the staff too, which you can see with the ladies holding the books in the picture below. And in 2021 we had a a secluded section, not really, like a dedicated section for ladies in AI, and it was really, really awesome. I mean, those who attended it can attest to that. We had 2 dedicated sections for ladies in AI to kind of create awareness around how we're supporting females in the community too. And we had experts come talk about their starting career path, how they also encounter challenges, to let others know that you're not, if you're facing any challenges right now, you're not alone. There was really interesting discussions around imposter syndrome, how you face challenges as a female in the field, how you can address it, how you can move on, how you can gain mentorship, how you can learn, and how you can thrive using that unique factor that you're a female in the data field, where we're not well represented, how you can take that as an advantage and thrive very well. So it was a very interesting section. And this year we're even making it bigger, especially with the launch of today's section, which is the first of the year. And we'll be having several others in the year. And we will really be very happy if you could join those sections. So before I introduce
I'm going. No, I want to see somebody here. My sister is staying here.
Okay. So before I introduce my colleague, before I call on my colleague to introduce the speaker for today, I would like to encourage you all to join the larger DSN community, because that's aside the online sections, the live sessions we have, there are a lot of interactions that go on in the larger community. Our Telegram groups for ladies in AI, the larger general DSN community. We talk about everything data, we share resources, we attend to questions and queries, and we try to solve problems together. So my colleagues will be dropping these links in the chat, and I will encourage you to pick up the links and join the community if you have not already. So I would be calling on my colleague Chinazo to please do us the honor of introducing our speaker for today. Chinazo, are you on the call?
Yes, I am. Thank you, Amina. Good evening from Nigeria and welcome everyone. I hope you're all excited to be here today because we have so much to learn. So our speaker will be talking on working effectively with databases. We know that building and maintaining databases is an integral part of handling data. So she's no other than the brilliant Opeoluwa Iwashokun. So Opeoluwa is a PhD researcher in applied information systems at the University of Johannesburg with a research focus on natural language processing. She has a background in computer science and information technology with over 13 years industrial experience in software development, data science, and related domains. She is technically sound in database platforms. So guys, please stay around and enjoy the session. Thank you. Is Okpe on the call now? Hello, Amina, can you hear me?
Oh, yeah, she's on the call. I can see her, but maybe she's having issues on muting. Okay, I fixed it. Hi, Ope, can you hear us?
Okay, yeah.
Yes, good evening.
Yeah, I was waiting for you to unmute me.
Yes, sorry for the challenges.
Okay, fine, thank you. First of all, I must appreciate every one of us. Thank you for making yourself available for this session. It promises to be a good one. This is a topic I'm passionate about, and it's something I've worked with at different points in time in my career. So let's get on quickly. Yeah, there is a poll on the Zoom call, but the choices for the poll is not showing correctly. The choices should be bad data or poor data. So please, I apologize for the choices that is displaying, but let's just get on the training slides now, and we can just do the poll by a show of hands. Thank you. So I'm going to be sharing my screen now. Oh, sorry, I wasn't showing my video. Can you all see my face? Okay, so let me share my screen now. Please confirm if you can see my screen.
Yes, we can see your screen.
Okay, good. Okay, yeah. Let me just turn off the video for us to just concentrate on the screen. Okay, yeah, so the topic before me is how to work effectively with databases. And I'll be talking more on data assets in databases. So in looking at data assets, we'll be seeing, of course, how to work effectively with databases. So, oops, okay, yeah, so the quick poll is a question to all of us that as data specialists, which do we think is worse? Do we think poor data is worse or bad data is worse? You could just type in the chat box. I would like to know from us what we think is worse. Is it poor data or is it bad data? Poor data is, let's say you have just little data to work with, or you have a lot of data to work with, but it's containing wrong data. So which do you think is worse? Let me see in the chat, please. Okay. Okay. Okay, good one. I can see we're all picking. Okay, yeah, there's a poor data there. Okay, good. Well, it's like 50-50. We have quite a number of people for bad data, quite a number of people for poor data. Okay, so as we move on into this class, we're going to see which is worse, if it's poor data or if it's bad data. Yeah, so we have instances of front office desk officers, putting in information. They are responsible for data entry, of course. And while putting in information, sometimes they skip certain fields that are expected in put in for such form. So in those cases, we have missing data. So most times, poor data is caused by human agents, right? As reason of missing data or sometimes wrong data. So wrong data, if you look at the comments here by this front desk officer, the comment is, I'll go over this question to the next one, that's missing data. If required, I'll leave it as the default answer. The default answer in this regards may be a wrong data. For example, let's say there's a field for age, and instead of putting in the correct age for that customer, the customer might not even have filled in the age data in the form. So that's another point wherein we have missing data. And sometimes the customer might fill in the age and then the front desk officer just puts in a default value. So when this data is entered into the system and it's the database, of course, we'll have wrong data, right? And wrong data leads to wrong information, leads to wrong insight, leads to wrong decisions. So to a large extent, bad data, wrong data is worse. If we have poor data, if we don't have enough data, we could make decisions based on the little data that we have, but to a large extent, bad data is worse. And one major way we can avoid it is, by ensuring that there are key fields that must be filled. If not, the form should not be submitted. Yeah, so those are ways we can implement. We can also implement it at the database on the database itself as trigger. So when a wrong data or a wrong information is coming in, then there's a trigger that will not allow this data to be saved. Okay, so yeah, so we can see from here that bad data, poor data is caused mainly, in fact, research shows that 70% of bad data and poor data is caused mainly by human agents. Now, one key way we can work effectively with databases is to have the right data, which is enough and which is right, which is correct and enough, right. So let's look quickly into this introduction. Data is something that is no longer just a buzzword, is something that we all know about. Data is everywhere. Data is like, we breathe data. Data is any collection of information. Data can be found in our everyday life, in our everyday doing of things. Data can be found in our mobile devices. Data can be found. I'm not talking about there's data for surfing, browsing. No, we are talking about data as information, data as records, right? So data is something that is found everywhere and is produced as we go about our various endeavors. Now, talking about databases, data collated from various sources need to be accumulated, need to be stored, and they are put together or accumulated in what we call databases. So database is a form of storage for our data, right? And then we have the database management system, which is a platform for storage and administration of data. We have various forms of database management systems. We have SQL, we have Oracle, we have Postgre, we have Azure, which is like a cloud database management system. We have many various examples that are in use today. Then we have the structured query language, which is used to manipulate data. So it's a unified way of manipulating data. So it's universally known and acceptable way of manipulating data. So then we have the NoSQL. The NoSQL is not like NoSQL, but it's just an abbreviation, which means not only SQL. So NoSQL is used mainly for databases that are not basically relational. So for relational databases, you use SQL. For non-relational, you use NoSQL. Then I'm going to touch on this as we move on into this talk, but I'm just putting context to each of these as a form of introduction. And we have the PLSQL. The PLSQL is an extension of the SQL statements, which is used to collate SQL statements and execute its syntax. So I'm going to show us that as we get on the hands-on as we move on into this class. So let's move on quickly. So our focus for today's class really is we're going to be looking at data as an asset, then data technology, and then data quality. From my own point of view, these are three main pillars for you to ensure working effectively with databases. Now, I started with the poll and the story of front desk officers, which most times are responsible for ill data or wrong data or bad data. Now, for us to work effectively with databases as data specialists, a key focus is we should ensure that everyone in the data pipeline understands the importance of data. So everyone in the data pipeline, starting with the data stewards, the data entry officers, even at management level, and everyone in interacting with the data in that organization must be aware of the importance of data. Now, when they are aware of the importance of data and this becomes a part of their daily tasks, then they would be able to put in right data, correct data, and avoid missing data. So this is a very key aspect. Now, another reason why at the management level, they should be aware of data as an asset is because data now is very key and relevant to many business decisions. So many strategy, many business focus these days rely on data. So when data is a key focus or seen as an asset at management level, then they can begin to make their decisions based on insights gotten from data. And then they can also begin to make allowances for improving on data infrastructure within the organization or investing in data infrastructure within the organization. So as data specialists in any organization or in any environment or in any research focus, we need to be able to make the people in the data pipeline to understand the importance of data such that business can begin to focus and strategize using data as an asset and not just data occupying space or data occupying the infrastructure, right? So data must feed into business decisions and business focus. Now, secondly, we also need to look at data technology. So data technology in this regard is both the hardware and the software that relates to data. So we need to focus also on the data infrastructure for data, the servers for data or data in premise, data in cloud, ensure proper data synchronization, ensure proper data storage and administration. Then I'll be speaking largely today on data modeling. You know, when data is being accumulated, the containerizations for this data must be properly modeled such that the data can begin to make proper insights when expected to, or when needed to, or when analysis is being done. And then the data architecture and the ETL across data platforms. So what I mean by ETL across data platforms is sometimes data comes in various sources. So the data technology must be able to cater for accumulating data from various sources using what we call the extract, transform, load process, which is the ETL process. Then thirdly, a third focus for effectively working with databases is ensuring proper data quality. So there should be processes in place that monitors data pruning or data curation, ensuring that data at all times is of good quality. You may not be able to attain 100% quality, but quality should be improved from time to time, or there should be processes in place that ensures improved data quality. Yeah, so those are three main focus for working effectively with databases: data as an asset, data technology, which has to do with the infrastructure and the software, the skills, and all the processes involved around data. Then ensuring data quality. Ensuring data quality is an ongoing process and is a process that one has to be proactive about by ensuring monitoring and by putting processes in place that ensures ongoing data quality. So now let's look at data as an asset. So I think I spoke extensively on this in previous slides, but these are some strategic questions we should be able to ask from time to time on data, on the use of data as data specialists. We should be able to understand the business focus in relation to our data. So whenever you are working with data, the data is not there just it's not there as, the data has a lot of potential use. So you need to put it to work. So you must understand the business focus and be able to relate it with the data. So to be able to align that, you should be able to know the kind of questions that management are asking about data. So for instance, let's say you're working in, or let's say you have data of a store, a large store, or a pharmaceutical store. You should be able to look at, you should be able to ensure that this data can bring up insights that either ensures profitability of the business or reduce cost. So those are, for every, of course, every business is in place to make profit. So what are those questions that the data can answer for you that can allow more profit in the business, or how can it assist to reduce costs? Or what kind of questions are management looking at? Are they looking at improving customer retention? Are they looking at improving the number of customers that are buying a particular product? So those are ways you can make use, you can begin to work effectively with your data to ensure that the data is an asset to the organization, or is an asset to your business focus or your research focus. Now, aside answering questions, of course, your questions can also lead you to how can you enrich your data set? The data set you have, what other data set can you add to it that could make it more informational? For instance, you want to begin to add, let's say you want to add more data on geographical information of the customers. You want to be able to know, oh, okay, what are their various locations, where are they staying, what kind of products are selling in those locations, do we have competing products in those locations? So those are ways you can enrich your data set such that it can begin to be more insightful to the business, right? So you must focus on data as an asset. That's one key thing I'm just trying to drive at. And these are questions that can spur you to know if this data is being positioned strategically as an asset or not. Thirdly, you can also check if the data will be used to increase revenue or to reduce costs. Then again, these are just a few questions I've placed here. Of course, there are more questions that you can ask strategically to make your data an asset. So your data should not be a cost center. A cost center meaning that, oh, there is data in the organization and we are spending money on infrastructure, we are spending money on cloud space and the rest of that. But this data should be able to feed back into business to be able to say, oh, based on the insight we have from this data, we have been able to increase profitability within certain period for business. You understand? So that way you can feed back data into business as an asset, and then this data becomes more profitable, and it can that way you are putting that data into effective use. Yeah. So next, we want to look at data technology. Now, for data, of course, to be effective, then the data must be organized. And it has to be organized in a platform. Now, the platform that we use most times for organizing data is database management systems. I've just placed on the screen here different management systems we can have, and different ones that exist in various organizations. And of course, there has to be considerations before choosing a particular database for your organization. Or, of course, let's say you get an organization and they are using a particular one, then you need to understand the reason why they are going with that particular database. So I'm just going to show us different types of database systems that are available. So the very common one is the SQL Relational DB. And this is because it's more transactional. It allows databases to be stored in tables that are relational in the sense that it speaks to okay, as we move on to the next slide, we are going to understand better what I mean by relational. But most common type of database management system is the relational DB. And for you to manipulate data on relational DB, you use SQL. SQL is a very, very important skill for anyone who is in the data specialization field. Now, we also have the NoSQL. I've talked a bit on that. This simply means not only SQL, meaning that your data in this can be stored as a key pair value. A key pair value allows for a much more flat data structure, and it allows for sometimes analysis to be done. But of course, there are ways we work around that on relational DB. I'm going to talk about that as I move on into this class. Then we have the distributed DB. For example, the Hadoop. Hadoop is not just a database management platform. It does a lot more than that. And for big tech organizations, they use Hadoop a lot. Then we have the hierarchical DB. This is no longer so common, but an example of it is the Delphi DB. Then the key pair value DB. This is also like a NoSQL DB type, and this is just an example. But our focus really, and the most common one, is the SQL Relational DB. Right, so these are considerations that one needs to look at before picking on a database platform. Organizational requirements. I think most organizations in Africa use the Oracle DB or the MS SQL DB. Then, of course, now many people are moving data to the cloud, and they use any of the big three tech cloud companies, either the AWS, the Google, or the they use any of those big three. So then we have you need to also consider the features, the licenses, the expansion requirements, and then the skill set for that platform. So now, still talking on data technology, I want to look at data itself and conceptual modeling of data. So having understood data as an asset, having understood that data needs to be stored in forms of databases or data management platforms, then we also understand how to conceptualize data. Now, proper conceptualization of your data and organizing your data will allow you to make proper sense of the data in the long run. But if there's no proper conceptualization and of this data, then we might not be capturing the right data. Now, in conceptualizing your database, you need to understand what the business focus is. And remember, the business focus is what we talked about as data as an asset. Now, your data as an asset, your understanding of data as an asset must feed into what the technology for your data is conceptualizing. Okay, so this is what I mean. For instance, let's say you are, okay, I have two examples on the screen. I have an example for a sales organization, and I have another example for a school database, for a school system. Yeah. So now let's look at the one on the left first. Let's look at the sales database first. Let's say we want to concentralize a database for a sales system. So now, what business understands is, in our sales system, we have customers, then we have sales personnel, then we have products. That's what business understands. And what business is focused on is, oh, we have products that we want to sell, and we must sell to customers. We need customers, right? Now, in all these various interactions, there is going to be data being generated. So you, as a data specialist, must be able to conceptualize all the various forms of data and create proper containers for which this database can be stored. Now, the database, of course, will contain your tables, and data will be stored in tables as rows and columns. Now, for you to create a database, you should be able to understand what are the different subjects and relationships, excuse me, relationship between these subjects to conceptualize your database. So, just like I mentioned earlier, this is already, drawn for us, or this is already, the concept is already displayed on the screen. But as we can see, we have customers. Okay. Sorry. Okay, so I want to, okay, good. So as you can see on the screen, you have customers. Customers who buy products. Now, products can be evaluated by a prospective customer. So you have two types of customer. You can have a prospective customer, that's someone who is yet to buy but is still evaluating. And you can have someone who has bought, then a customer. Then you have a salesperson who markets to the customer. You have a support rep. So this is just an example of creating the concept for your database. What is pertinent here is that every of the subjects is represented, and each of these subjects is what will then form our tables in our database. Okay, I'm going to move on quickly because of time. We have the school database as well. You can see that each of the subjects in the school is represented. Like you have the teachers, you have the students, you have the classes, and we can then begin to look at what are the relationships between them. Now, conceptual modeling of data entails three main things. Now, the entity usually is like the noun in your interactions, like your like the entity of a customer, entity of a salesperson and things like that. Now we have the attributes. Attributes are the properties of the entity. Now, when creating your database, the attributes forms your features, right? It forms your columns. We're going to do that quickly. Then we have the relationship. So your relationship is going to show the keys between your customer and the product. So, so that's about conceptualizing your business into your data technology, and that's what we call modeling. So that's part of the process of data modeling. So in creating your database, you must be able to understand the entities and then be able to conceptualize that into what will form your database. Then you have your logical modeling. You can see this is more robust. This is for the school database. So it then shows the attributes and then shows the various keys and relationship between them. Now, the physical modeling is when we then have the primary keys, the database features, and then you can create the relationships, and we create this on the database management platform. So I'm going to allow us to quickly move on now. I want to show us quickly how to create such on the database environment. If you have your database management studio, that's MS SQL Management Studio installed, you can just follow through with me on this exercise. But what I'm going to do quickly is to show you how to create a database and how to create your concept into a database. So let's say you can just come here, create a new database, and let's call this a school database, a school DB.
Yeah, hello, Mrs. Ope. We are still seeing your PowerPoint slide. We're not seeing your database.
Oh, sorry. Thank you.
Yeah. All right.
Can you see my database now?
Yes.
Oh, okay, fine. Okay, so I created a new database. I called School DB. Let me close this other ones. Okay. Yeah, so to create a new database, you just click new database, and then new database is created for you. Put in a name for your database. So I put in School DB and then just click OK. Right, so now remember we talked about entities and attributes. So the entity for a school, we said an example can be students, classes, teachers, and the rest of that. So let's just see how to create one of them as a table. I'm not going to go into so much detail for this, so but I'm just going to show us briefly. So you have student ID. Now your student ID is usually like a unique way of a primary key for identifying your student. They're not going to allow null. Then you can have like your student name. That should be stored in what we call a variable character data type. So this is the physical modeling point now. At this physical modeling point, you are creating your attributes in your tables and you are putting a particular data type to it. So of course, you need to, for character fields, of course, you need to specify VACA. Then for numerical fields like your ID, which is not expected. For this type of ID, you want to use an integer. You can have an ID that contains character values. So student name, you also want to know the address, and so on and so forth. Yeah, so this is just an example, a quick example of how you can create a table in your database management system, right? That stores data that will be coming in from various data sources. So this is an example, right? But because of time, what I did was to create earlier before the class a database system that captures the data modeling we are talking about. Now, a second database model that I put on the screen for us was the hospital. I wanted us to create this together. Okay, so I said, let's set up a database for a hospital system together. So now let's look at the data structure, data modeling for an hospital. So what I did was to, can you see my, okay, I hope this is not too small, this is not too tiny. Let me enlarge it. Can we see it? Can we see my screen?
Yes, we can.
Okay, good. Okay, so for the hospitals modeling, for a hospital database modeling, of course, an hospital is going to have doctors. What are the details about a doctor that you want to, about doctors for an hospital that you want to capture? You want to capture these various details about them. Then the hospital is going to have employees as well, right? So employees, these are the various details about an employee. And then the doctor as well is an employee. So you can see a doctor as an employee ID, right? And as other details specific to the doctor. Then a doctor could have various specialization. Under doctor ID, you have specialization ID. You have the details of those specializations specified under the specialization master table here. So you can see that when modeling a database, you need to capture the various entities, and then you need to capture their features as attributes under them, and then create them as database. This form of database is what we call a transactional database, and it's always in a relational form. A relational form in the sense that each entity is created as a table, and then there are relationships between them. To make this clear to us, let me create something like a database diagram. Okay, so let me come up with, let's start off with employees, the hospital has employees. Okay, so good. So now you can see that we have employee ID as a primary key. I showed us what primary key means. Is a unique identifier for records in your table. Now, there's another table that relates to employee, and that is the doctor's table, right? The doctor's table has what we call the employee ID. The doctor's table has the employee ID, meaning that a doctor is also an employee in the hospital. So the doctor ID here is a primary key, but the employee ID in doctor's table is a foreign key. So for us to show the relationship between doctors and employee, what we need to do is to show the relationship by mapping the employee ID in employees table to employee ID in doctor's table. Now, this will not be allowed because I'm yet to create the primary key on each of these tables. So let's do that. To create the primary you just simply go to the design on the table. So under doc ID, I will right click and say set as primary key. Under employee ID, under employees table, I right click and say set as primary key. So ensure to save. So now we can go back to our database diagram and create a relationship. So now we'll just drag employee ID to employee ID. You can see it's showing the primary key, foreign key. Just say okay. So yeah, with this you can see a relationship between employees, employee table. Of course, we can create the other relationship, like the patients table as well. Yeah, but because of time, let me go back to my slide. This is how to model data. So you can see how we came from understanding the subjects in the business area and translating it into tables and entities and creating relationships between them and physically creating the database on the database management platform. Okay, so yeah, so now I want you to also think deeply on any form of data endeavor that you might have ongoing or you might want to go into. For example, let's say you want to do some work on out of school children or on government intervention for poverty alleviation or climate changes, then you need to sit down and think, what are the subjects, what are the entities in this data research work or in this data organization. Once you are able to see the entities are usually the subjects or the objects in that interaction. Once you're able to get the entities, then you begin to draw the features, the attributes. Those forms your columns for which you can then create your model for your database. So that's how to create a proper database. And just like I said earlier on, your database model is very, very important for ensuring proper data collation and ensuring that important data facts are not left out, right? So now, what we have done or what we have worked on and what will be presented with most times is what we call transactional database, right? Just like you can see on my screen. Now, when doing analysis, you can't have enough insights from your transactional database. You need to be able to translate your transactional database into what we call an analytical database. Now, an analytical database has more of a flat table structure. Now, a flat table structure in the sense that tables are merged or informations are collated from various sources into usually just one flat table source. Now, when you have an analytical, when you have a flat table source, for example, we can create a quick one. You can create a quick one by simply merging tables. So for instance, let's say business is asking question on, oh, who are the doctors that are specialists in how many doctors do we have that are specialized in certain areas in the hospital, or what's the percentage of the specialized doctors that we have, right? Those are just simple basic questions, right? Or what level of profit have we made in the past few months, right? Or what ailments are our patients presenting at the hospital most of the time. So when you have such questions, you need to be able to dissect the questions and look at what tables will I need to be able to answer this question. Let me take an example of, okay, let's see, we have patient bills here. Okay, and we have patient details. Okay, so now flat table structures will usually come in aggregates. So let's create a merge of our patients and our patient bills. So let's first of all select from our patients and see what we have there. Right, so we have patient details here, and under patient bills, we can see we have the details on bills made by patients. Okay, that's not this. Okay, so usually when creating flat table structures, you want to begin to aggregate. So, okay, yeah, we need to also know the details of our joining factor. So if we want to get information from patient and patient bills, you need to be able to create a join. So I'm going to select everything from patients. I'm going to do a left join. So left join in this case simply means give me everything from patients, right? And the joining factor will be specified using the on tag. So join patients on, of course, the patient ID. I already showed us how to, what we mean by foreign key and primary key. So patient ID will be used to join both tables. Okay, so you need to specify which patient ID you are picking that from. Okay. Just a second. Patients, oh, sorry, patient's ID. And okay, so we need to be able to create a flat table structure on both tables. So of course you need to use the joining factor. I don't want to pick all the fields. I'm just going to pick a few fields that we need. Patients. So let's pick just okay, let's pick just patient ID. Okay, let's just pick states. We want to look at things like age, state of the patient, and let's look at aggregate values on the bills. Let's click on bill amount, right? So let's say we want to sum the amount paid by patient of certain age value, of certain age brackets, right? So, or no, let's aggregate on okay, so we need to introduce a group by clause here because we're putting in an aggregate. So these are ways we can create flat table structure from transactional table. We need to be able to write transactional SQL statements that will allow us to create those flat table structures. So when you have a flat table structure like this, then you can begin to make inferences or create basic analysis. Let's look at, okay, state or city. Let's look at city instead. Let's aggregate on city instead, right? So, yeah. Okay, so in this case, you have missing information on city, but this is just an example of how you can, create aggregate data from your transactional table to now start making insights, right? And in a proper setting, you might want to separate your transactional database from your analytical database so that you can work effectively. What the client usually present to you is a transactional database, right? With your data specified just as I've shown you this way, your tables modeled, right? But then you have to be able to aggregate to create what you have, to create a database that you can use for analysis. Differences between transactional and analytical databases is that the transactional is relational. The analytical database is usually in a flat table structure format. Then in the analytical table type, you begin to introduce redundancy. Redundancy means that sometimes you have repeating values or null values, right? Just like you can see here when I created a merged table, we have some null value for certain cities, right? But of course, you can make inferences from the null in that regard. The null in this regard means that there's no data for that particular city. It doesn't mean that data is missing, right? Then transactional databases are fast for retrieval. So for everyday use, transactional databases is what organizations will make use of. But for analytical databases, you use that for analysis. So they might not be as fast for retrieval of data like you have in transactional database structure. Then transactional database is more discrete. I talked about, or I wrote somewhere about the first about normalizing your data. So in transactional database, you normalize your data such that it's discrete. Every table contains just an information. You don't accumulate or aggregate information in tables. No. So you normalize up to maybe second or third normal form such that data is discrete. But in analytical database, you aggregate data and you can use that for analysis. So when working with your databases, don't mopple up or don't put your transactional and analytical tables in the same bucket. You need to be able to separate them. You need to specify tables for your aggregates and use them for your analysis, and then leave your transactional or relational tables, leave them separate. You can have them in the same database, but ensure to separate them into different tables, right? So that's another important way of working effectively with databases based on data technology. Because of time, we are not able to do a lot of hands-on like I would have loved us to in this class. I can see that the time is already fast spent, but the points of you working effectively with databases is what I really want to drive across to us. That we need to understand data as an asset. We need to understand the data modeling techniques of working with data in data technology aspect of things. You need to understand the various concepts that are presented to us on relational databases, how they are different from your analytical databases, and how you must structure them differently. Then lastly, I'm going to move on to understanding your data quality and constantly improving on your data quality. Now, your data quality depends largely on a good database design. Now, if you look at these 3 focal points that I mentioned at the beginning of this training, of this talk, you will see that they flow into one another. Data as an asset, the understanding of data as an asset for every person in the data pipeline is very important to the effectiveness of data technology. Now, the effectiveness of data technology, the proper modeling of your data is also very important, effectiveness of your data quality. If the modeling of your data is faulty, then you are likely not to have a good data quality at all. So the data modeling technique is really very important. And this also fits into our data quality. Now, ensuring data quality means that you should be able to have a proper database design which captures every subject of your business focus, every subject of the organization, like we are modeled in while we're doing data modeling, right? Then every of this information must provide access that allows you to be able to join your tables together. So your tables are not discrete, they are relational. You must be able to have joining factors within your table. For instance, remember we looked at schools database system. We also looked at sales database system. We also looked at hospital database system. How each of these tables have primary keys and foreign keys, which you can use to join your tables together and then be able to form an analytical flat table structure. Now, it is from that analytical flat table structure you can then begin to make analysis and create insights, right? Then your data quality, good database design must also ensure proper accuracy and integrity of the information it's holding, right? And it should, of course, accommodate your reporting needs. Now, another important factor for we will not be able to do this hands-on because of time, but a proper way of creating, you need to be able to create a flat table structure in readiness for any exploratory data analysis. I would like you to do that on your own based on any form of data you have, or you can reach out to me after this time for guidance on how to create flat table structure from your transactional DB. Right. So a second data quality, a second data quality we must factor we must ensure is to curate our data. Now you can't have 100% clean data. That's taken. You can't, but you should be able to ensure that from time to time processes are put in place to ensure that your data is cleaned. And whenever you want to do analysis, of course, most of the time you spend about 70% of the whole process of data analytics process for cleaning the data and ensuring consistency in your data. So you need to be able to study the data, identify any inconsistency or duplicates in your data, identify missing data, incorrect spellings, outlier data. Outlier data are data that are unnecessarily different from every other data. So for example, let's say we are looking at outlier data sometimes might not be incorrect. They might be correct, but of course you need to treat them separately so that you can get proper insights from your from your database. Then of course you need to look at you need to be careful of things like not a non appearing in your numerical data. So these are ways you ensure that your data is clean. Then another proactive means of ensuring data is cleaned at all times is putting proactive measures in place, what we call your data governance in place. So data governance is means of controlling the use and the use of data within the organization, the use of data or the interaction with data within the organization. So when you put data governance in place, then within the organization, there are measures for which data standard is maintained. And then it can, of course, be a proactive measure of ensuring proper data quality. So I'm going to end the talk here. It's already 20 minutes into our time. I'm sorry for taking your time. I wanted us to do quite a bit of the hands-on, and that took a bit of the time. I think an hour is too small for for the training and the hands-on, but I hope we got the 3 pillars of working effectively with data, and we can, as data specialists, apply that to our working and our understanding of working with data in our various endeavors. And that is data assets. Everyone in the data pipeline must understand data as an asset, right? Then the data technology, you must ensure proper data technology is in place, both in infrastructure, both in data modeling techniques, both in performing ETL across various data platforms. In today's talk, we looked briefly into data modeling techniques, how we can model data to ensure that business focus is captured and you can derive insights from the data. Then lastly, you must ensure data quality. And data quality is both ongoing and proactive. Ongoing monitoring process must be in place to ensure data quality, and proactive measures like your data governance as well must be in place to ensure continuous data quality. Thank you for listening.
Thank you so much, Mr. Fair. That was a great session. Thank you so much.
Thank you, sir.
Yeah, I agree with you that 1 hour is short of a time. I mean, would have just kept going on and on because the section was quite interesting. especially the hands-on part. I'm sure people would have enjoyed an in-depth session on that part. But I think we can do this again, maybe some other time.
Yeah, sure. And with a much more span of time. 1 hour.
Yeah. Yeah. Yeah, I agree with you. Thank you. So we have some questions on the just one though. We have a bit of time, so if you have any questions, you can drop it in the chat and also in the link we've been sharing for the questions. This question was about, can you talk a little on SQLite and MongoDB?
Hello?
Yeah, Mr. Beck, can you still hear me?
Yes, I can.
Okay, I said someone was asking about if you could share some light on SQLite and MongoDB.
Oh, okay. So I will talk a bit about SQLite, but I will not be able to talk about MongoDB because I haven't used that for my work at the moment, but I'll talk about SQLite. So SQLite is just like SQL, of course. It's also a database management platform that uses SQL. So it's relational, and SQLite, I think they use it most times for mobile applications because it's quite interoperable with many mobile applications platform. So yeah, SQLite can be used a lot in that regards. Yeah.
All right, thank you very much. We have some more on the chat. There's a question on, please, when you are given a very large data set to extract for your analysis, I know my entities, but the data set is so large, I do not know where to start from. What do I do?
Oh, fantastic question. I like that. So when you are given a large data set for your analysis, I want to assume that it's a flat data structure that you're talking about because you're saying a large data set. So when you are given a large data set, what I'll usually do is I look at that data set in a reverse form, like what are the subjects or what are the entities that are available in this data set. So even if it's in a flat structure form or in a relational form, you can relate that question. You can relate it to the subjects. Now, if you're able to identify the subjects or the entities successfully, that will guide you into the kind of insights that you can derive from that data set. For instance, if I'm able to identify, let's say the data set has to do with a pharmacy. If I'm able to identify entities like drug, like customers, like vendors or suppliers from that large data set, then it will guide me into the kind of questions or insights that I can derive from the data set. And that way, once I'm able to note the questions or insights, that way I can then begin to make my analysis. Now, when given a large, that's the starting point. Now, when you want to do the work, you're not going to pick on all the fields at the same time. I'm going to look at the question I want to answer, the insight I want to derive, and then I'm going to pick on attributes or fields that relate to that question. Extract those using my SQL statement, of course, depending on the platform I'm using. Extract those into a separate table. Of course, when I do that, sometimes I'm going to introduce redundancy. I might have some repeating columns, but that's fine. Once I'm able to extract that into a separate table, I can then create aggregates your analysis is always based on aggregates. Your analysis is not going to be based on discrete table values or columns. Are you getting? I hope you are getting me right. I have experience in working this way, so I know what I'm saying. So when you extract it into a separate table and create your aggregates, then easily you are going to derive your insights and, of course, be able to bring out some very interesting findings from that large data set. I hope I answered your question well.
Yes, the person responded that you answered the question.
Okay, great.
So we have one more question. It's about starting as a database manager. What are the requirements? Say the person wants to work as a database manager for a company.
Oh, good question. If you are working as a database manager, then you need to, in fact, what we did today is for you. That's the data modeling is for you. Your data modeling technique must be top-notch. Now, you working as a database manager means that you should be able to understand how data works. And how data works really is based on data architecture, data modeling, your ETL processes, and the likes of that. So you must understand data modeling techniques. And that way, let's say you get into the organization and of course you already have an existing database. Your first assignment is to sit down with the database and understand the entities and the relationships between them, right? And from that on, you need to understand how to administer your database. Of course, you need to take it deeper than we did in today's class. You need to be able to write a lot of SQL, manipulate your data, and create things like backup, archive, and other processes around, working with database. Yeah, but yeah, the data modeling technique is very, very important for you to understand how the database within that organization works, or for you to be able to create a database for that company if it's a company that is just starting off new.
Thank you very much. We have one more.
Okay.
I would like to know why PostgreSQL is considered as a NoSQL. I'm thinking it's a relational database.
Oh, great question. Yeah, it's the NoSQL name is sometimes confusing. NoSQL does not mean not SQL. It actually means not only SQL. So PostgreSQL is beyond relational, right? So apart from it's being able to, it's able to store databases that are also beyond relational DB. Like you can do your key pair value in PostgreSQL, you can do like hierarchical flat table structure in PostgreSQL. So it's not necessarily a relational DB actually. So yeah.
Okay. Can we take one more question?
Yes, sure. Someone is asking, how do we import transaction data into our database? Yeah. I'm sure. Okay, so there are two methods actually. I wanted to cover that in this class, but because of time, I couldn't do that. What I did was just to import my data before the class. So, of course, when you have various data sources, you need to import those data into your database management system. One method you can do that in Microsoft SQL platform is to use the SQL import and export facility. you can see that under your, can you see my screen? Am I sharing your?
Yes.
Okay. Okay, so just go to your SQL Server installation, and you are going to see this tool, SQL Server import export data. So you can use that to import data and to even export data out of your management, SQL management system. A second method is you can use the SSIS package. The SSIS package comes as an integrated, so you can view the SSIS package from here. You just need to connect into integration services. When you connect into integration services, you see your SSIS package. So that's the second method you can use to import data into your database. And of course, various database platforms have different methods that you can use. Sometimes they come as an additional facility, utility rather, that can be used to import data into the database management system of your choice. Okay, any other question?
I think that's all we have. Yeah.
Okay. Yeah.
Okay, I can see one on how long does it take to be a good database analyst?
Well, it depends on individuals and constant practice. So there's really there's no hard and fast rule about it. But for me, in every of my learnings, I always try to ensure that I understand the basis. When you understand the basis, the clear basis, then it's easier for you to build on them. One of the key bases of being a database analyst is what we have discussed in today's talk. And those three pillars are actually very important. If you can understand them and work effectively with them, understand the tools around them, understand the technologies around them, and practice with them, then of course you will be a fantastic database analyst with time.
Thank you so much, Sophie. I think that's all we have. Yeah, I think that's it. So thank you so much once again. It was a great session. It was really, really awesome.
You enjoyed it, even though the answer time was really short.
Yeah, we apologize for that. Hopefully we'll get more time next time.
Okay, great.
Yeah, thank you so much. And thank you
Pleasure.
to everyone. Yeah, thank you to everyone that has joined today's session. We hope that you enjoyed it and you learned something new, and you've been inspired to continue on your data journey, whichever path you're taking. Once again, you can join the larger DSN community for follow-up questions, for connecting with other people, other awesome ladies, and the larger community as well. You can work on group projects together, you can study together, and you have great network there also. And would have another technical session for ladies in AI in few months time, and so keep your ears for the dates and when it will be released. Thank you all once again, and enjoy the rest of your day and have a great weekend.